Hello everyone, I'm Arush
And I am Naveen.
and today we are going to be sharing with you about similarity and we will first walk you through some of the tests of similarity which can prove whether two triangles are similar or not. Then we will be covering intercept theorem and then we will show you an example problem. So firstly I'll talk about the rules for similarity. So we will start off with AAA. So as you can see here, two triangles are similar if two of their angles are equal. So in the diagram, if angle A is equal to angle P and angle B is equal to angle Q, then triangle ABC is similar to triangle PQR. So similarity means that it's scaled by a factor, which means that all the angles of the two triangles are the same, but each of the sides vary with the corresponding sides by the same factor. So this first rule is known as the AA rule. Now I'll talk about the proportionality rule of similarity. So this is called SSS. Two triangles are similar if all the three corresponding sides are in the same ratio as I said earlier. So if PQ in the diagram, if PQ over AB is equal to QR over BC, which is equal to PR over AC, which is equal to K, which is the constant of uh, which each of the side is multiplied by to give the other sides, then triangle ABC is similar to triangle PQR. This is known as the SSS rule and there's a example given below. Lastly, there is the SAS property for similarity. So this property states that two triangles are similar if two of their sides are proportional and the included angle between those two sides is equal. So in the diagram, if PQ over AB is equal to QR over BC, which is equal to K, and angle B, which is equal to angle Q, which are the included angles for the two triangles, are equal, then triangle ABC is similar to triangle PQR. So this is known as the SAS rule and there's an example below to illustrate it. Now I will pass the time to Naveen to explain about intercept theorem.
Hi. So now we're talking about the intercept theorem. So for the diagram on the left, we have two triangles, SAC and SBD, and the and AC and BD are parallel to each other. So when this type of instance occurs, we can use the intercept theorem to find some useful ratios of the sides. So firstly, we can find out that SA over AB is equal to SC over CD. Then we can also find out that SA over SB is equal to SC over SD. So what we're basically doing here is we're taking the lengths of the sides on one side and basically mirroring it over to the other side. So on the diagram on the right, we're doing basically the same thing, but just that the second triangle is on the right this time. So SAC and SBD are still similar because CSA is equal to BSD and CA is parallel to BD. So because these two triangles are similar, we can use the intercept theorem to again find out the useful ratios, like SA over AB is equal to SC over CD. So the ratios given above apply to both diagrams. So that's basically in the intercept theorem, and this will come in handy for quite a few math-only questions. Now I'll be talking a bit about the example question. So we have a diagram where AB is parallel to EF, which is parallel to DC. So we have AC plus BD is equal to 250 and BC is equal to 100 and EC plus ED equals to 150. So we need to find CF, and if you want to solve this question, you could pause it now, and here's a hint, you need to use the intercept theorem. So if you have given it a shot, I will be presenting the first part of the solution. So firstly, since EF is parallel to AB, we can find out that EC over AC is equal to FC over BC by the intercept theorem. Following which, since EF is parallel to CD, we can also find out that BE over BD is equal to BF over BC. Now, because BD minus ED over BD is equal to BC minus FC over BC, we can separate this into two separate fractions and cancel out BD over BD. So we can get 1 minus ED over BD is equal to 1 minus FC over BC. So we can hence figure out that ED over BD is equal to FC over BC. Now I'll be passing the time on to Arush to complete the solution.
Okay, so continuing from where Naveen left off, we can see that EC over AC is equal to ED over BD as mentioned earlier because we want to make use of ED over BD is equal to FC over BC to find to find a ratio which could help us solve the problem. So thus EC over AC is equal to ED over BD, which is equal to EC plus ED over AC plus BD, which, and you can take note that adding ED and BD to these does not affect the ratio actually, as A plus B over C plus D is the ratio is the same. So thus this expression is now equal to 150 over 250 as given in the diagram, which is equal to 3 over 5. Thus as ED over BD is equal to FC over BC as shown earlier, then FC over BC is also equal to 3 over 5. Then we know that FC over 100 is equal to 3 over 5, and thus FC equal to CF is equal to 60, and thus we have solved the problem. Thank you for listening.